Chapter 22, Problem number 49. The Earth's magnetic field, like any magnetic field, stores energy. The maximum strength of the Earth's field is about 7.0 times 10 to the negative fifth Tesla. Find the maximum magnetic energy stored in the space above a city if the space occupies an area of 5.0 times 10 to the eighth meters squared and has a height of 1,500 meters. So I immediately looked at my equation sheet and I noticed this equation right here. Energy density is equal to 1 over 2 times this value right here. This is known as the permeability of space constant, times this squared. This right here is the Earth's field, which is 7.0 times 10 to the negative fifth Tesla. Like I said before, this is the constant. And we have the energy density on this side of the equation. We have this and this, but our problem is we need to figure out another way to express this right here. And another way to do that is by taking the magnetic energy divided by or per the unit volume of the space that we're looking at. So the energy density is equivalent to the magnetic energy. This is what we are looking for, per the unit volume. The right side of the equation doesn't change. We are given this is what we are looking for, and we are also given the unit volume, except we're not given the volume value itself, we are given the height, and we're also given the area. When you multiply the height times the area, you get the volume. So, let me just rewrite the equation by multiplying each side by the height times the area, or multiplying each side by the volume, in order to put all of the known values on one side and have the one unknown value, or what we're looking for, on one side. So the magnetic energy will be equal to times the height times the area. This right here is the volume. This is what we're looking for, and we have all these values right here. So from here, all we have to do is start plugging in. This value right here is the permeability of space constant, and it is equal to 4 pi times 10 to the negative seventh. This is the Earth's field right here, and it is 7.0 times 10 to the negative fifth Tesla squared. The whole value is squared. Times the height, which was 1,500 meters, times the area, which was 5.0 times 10 to the eighth meters squared. All we have to do is plug in these values into our calculator. And you should come up with a magnetic energy of 1,462,236,040 joules, or you can write that as 1.5 times 10 to the ninth joules. So just to recap what we did, we were given this value, this is a constant, and this was the energy density, this was the equation on our equation list. The energy density can be expressed as the magnetic energy per the unit volume. And we were also given the volume in the equation because we were given the height times the area, and that's how you get volume. In order to bring the unit volume from the left side of the equation to the right side of the equation, I multiplied each side of the equation by height times area, and so I was left with the magnetic energy is equal to 1 over 2 times the permeability of space constant times the Earth's field squared times the height times the area. And this is how I found the magnetic energy, just by plugging in the values into my calculator, and just be sure to square this term right here. The final answer is 1.5 times 10 to the ninth joules.